Hi. Now, you should already be familiar with the Cartesian coordinate system, where we can define any point in a plane with reference to an x-axis and a y-axis as having coordinates xy. We know that the displacement from the origin is given by x, and the displacement from the origin in the y direction is given by the coordinate y. So we've got that this is x and this represents the displacement y. Now, it's not the only way that we can define a point in a plane. We have another system which is using something called polar coordinates. And to work out the position of a point, what we do is we take a line, okay, and this line is like the x-axis, but it's not called the x-axis, it's called the initial line. Let's just write that in. It's the initial line. And instead of having an origin here, we have this endpoint here, which is, we'll call it the 0 there, but it's called the pole, okay? And instead of having, say, a y-axis, you quite often see an axis that is dotted like this, okay? And you might extend it back in that direction. Now, to define a point, say like this, in that position, we can define it by taking a particular length from the pole here out to that point. So, if I say that we take a certain length, that point could be anywhere on a circle with the centre at the pole. Now, to fix it, we not only need to define the length, but we need to say what angle it makes with this initial line. So if we put an angle in here, we'll call that angle theta. And we have to define a positive sense, and the positive sense is always taken as anti-clockwise. So this length here is referred to as r, and our angle here is theta. So this point on the end here, instead of having coordinates xy, has coordinates r theta, written in that order. And this line here, our initial line, you'll often see labelled as theta equaling 0. Now, it might say 0 degrees or it might say 0 radians. You can measure theta in degrees or radians. But do remember that the sense of it is positive in an anti-clockwise direction. So, if I had something like this, let's just draw you up an example, very quick one. So if we had, for instance, a point in a Cartesian system, okay, we've got our x-axis and we've got our y-axis, and that point was, say, the point A. And A had coordinates, let's say, 0, 2. Then if we wanted to represent this point as a polar coordinate, then what we would do would be to draw our initial line, and suppose we were saying that it was measured in degrees, then theta would equal 0 degrees. We could put our dotted line in here for what is essentially the y-axis, and we could extend it back in that direction if you like, and we would label our pole as 0, and then the point A would be up here, okay, this would be 2 units, and the angle in here would be 90 degrees, okay, so just mark that in as 90 degrees. So the coordinates of A written in polar form would be r, which is 2, and the angle would be 90 degrees, 90 degrees. It's not the only way that we could write that up. We could say that A could be represented in radians. if it were, it would be 2, and in radians it would be pi upon 2 radians. And I could write a c here representing radians, or just leave it without any indication. If there's no sign here, it's just understood to be in radians. Again, it's not the only way that I could write A. I could write A as having coordinates 2, but turn in the opposite direction, the clockwise sense. And if I did, this angle starting from 0 would be to turn minus 270 degrees. So you could say 2 minus 270 degrees. And it doesn't end there. You could even say that A in radians was 2, and then turning in a clockwise sense, which would be the negative sense, it would be minus 3 pi upon 2 radians. And again, I could write a c there for radians, or I could just take it off and just leave it as minus 3 pi over 2. Okay, so this is a very basic example. So what's it like in general when we look at any particular point? Well, in general, what we've got, if we've got our axes, okay, our Cartesian set of axes, and we label them x and y, okay, we've got our origin here, then suppose we've got a point here, we'll say it's got coordinates xy, it's a point P with coordinates xy. We know that if we were to go in that direction, it would be x units. We know if we go in that direction, it's y units. But to express this in polar coordinates, we would need to work out this distance here, r. And that's easy to do because by Pythagoras' theorem, r is going to equal the square root then of x squared plus y squared. Okay, so we can easily get what r is. As for theta, okay, in here, we can get that very easily because that is just going to be the tan of theta, which equals the opposite over the adjacent side. Tan theta equals y over x. Or if we rearrange that for theta, theta will be the inverse tan of y over x. But we're going to need to take care in problems like this when we're trying to work out what theta is, because our point P could well be in second, third or fourth quadrant. So we'll do examples on this later, but we do have to take care over that angle theta. So for something like this, represented then on a diagram that illustrates it in polar coordinate form, this line, the initial line then, is where theta equals 0, whether it's degrees or radians. This point here on the end, O, is our pole. And if we're going to put some axes in here, we tend to do them in as dotted lines, okay? Some people do leave them off, it's up to you, okay? And then we've got our line R, okay, going out here. At the moment, this could represent any point on a circle with radius r, centre O. But we're looking for this point P here, and so that point is fixed if we know this angle in here, theta. And we say that it has polar coordinates r theta. All right? So this is something then that basically you need to learn, and we'll just box that round. Now, in this series, what we'll do is go on to show how we can take a general point P with Cartesian coordinates xy and convert it then to polar coordinates just by using this concept here. And we'll also do the reverse, taking a polar coordinate and converting it to a Cartesian coordinate.